Okay, and it looks like we are live. Hello, everyone. My name is Jasper. I'm the Growth Marketing Manager for the cloud at EDB. I'm going to be your host today for our webinar on top 4 considerations for adopting cloud database services. I'm joined today by Christina Wong, Senior Director of Cloud Marketing, and Vinnie Grack, our Senior Cloud Architect here at EDB. Before I turn it over, I'd like to review just a few housekeeping items. Firstly, the presentation today is being recorded. We will be sharing a recording along with the slides after we're done with the broadcast. Just keep in mind, it may take until about this time tomorrow until we can get you that recording. Secondly, please note that your lines are currently muted. We do expect the presentation to last most of our time today, but any extra time we do have at the end of the presentation will be used for Q&A. If you do have a question, please feel free to submit that into the Q&A panel. I will be scanning the chat for questions, but it's much more likely I'll lose track of them there, so please use that Q&A panel. If we don't have time to address all the questions, we will do our best to keep looking through them and get you an answer. So with that, I will hand it off to Christina to kick us off. Christina, go ahead and take us away.
Thanks, everyone. I'm just gonna share my screen. Hi, everybody. Welcome to our webinar. I'm so glad that you could join us. We're going to be talking about top 4 considerations for adopting cloud database services. And just a quick introduction, my name is Christina Wong, and I'm the Senior Director of Cloud Marketing here at EDB. And I'm going to let Vinnie introduce himself.
Hi, everyone. I'm Vinnie Grack. I'm a Senior Cloud Architect here at EDB.
Awesome. Thanks. And so what we're going to do today is we're going to talk about why companies are moving their data workloads to the cloud and what we're seeing in terms of use cases and best practices. But mainly what we're going to do today is we're going to have a fireside-like chat about what we've been seeing and what we've been hearing and what we've been learning, so that as you go through your cloud database journey, you can keep in mind what considerations you'll want to think about and the decisions you'll want to make and the challenges that you'll need to look out for. So we're going to share our stories, but we want to hear from you too. And as we talk through the various different topics, please put your questions in the Q&A and I'll try my best to address them as we go. If we run out of time, we'll be following up with you after the webinar and we'll do our best to do that. So let's get started. We know that everyone's moving to the cloud. In fact, in 2020, analysts such as Deloitte told us that tech spending overall decreased. However, spending on cloud solutions increased and grew even faster than the year before. A lot of this was driven by the world's response to COVID. Lockdowns and work from anywhere led to organizations to find new ways of communicating and doing business and delivering value. And other organizations came up with new offerings to help them accomplish this. How do we know that cloud spending accelerated? Well, these analysts looked at a number of different factors, and they looked at obvious ones, such as like cloud workloads and revenues among public cloud providers and cloud traffic. And they combined it with other indicators, revenues of semiconductor companies, data centers, telecom network traffic, and more. And so all these signs, they all pointed to a trend that the adoption of cloud solutions were booming. The question is why? Businesses don't make a move like this unless they have something to gain from it. And many companies are seeing younger organizations leapfrogging them in the market. Competition is really fierce, and the lack of face-to-face interactions are forcing companies to do business and deliver business in different ways than they have in the past. Moving to cloud provides companies with the ability to do more of their applications and data, elastically scale out and back in, be responsive to changing markets, and have the agility and flexibility to compete by quickly pushing out new applications and updates. However, it's not just about doing more. Organizations can save and do less using the cloud as well. They can do things like offload overhead activities to the cloud vendors. They can use their resources more efficiently with consumption-based models and pricing. And routine activities such as maintenance and updates can be automated and save them time and money. So many organizations are aggressively investing in a cloud-first strategy, and you may be as well. And so the question isn't, should we adopt cloud databases, but how do we adopt cloud databases? And I'm going to talk through some of the key decisions organizations will need to think about when implementing databases in the cloud. One big decision, of course, is what type of cloud environment to deploy in. Unless you're a small startup, it's very, very likely that you'll be deploying applications and databases in more than one type of environment. And it won't be just on premises or just in the public cloud or only in a private cloud. That being said, there is a significant shift away from on-premises to other types of environments. They're finding that CIOs are expecting on-premises proportion of overall workloads to drop from 59% in 2019 to 38% in 2021. And where are those workloads going? Well, if you look at the top IT spending drivers in 2020, it was migrating to public cloud or expanding into private cloud. And the study found that 35% of workloads would move from on-premises to public cloud, and 20% would move to private cloud, and then 7% would move to hybrid cloud. And speaking of hybrid cloud, this same study predicted that 90% of global enterprises would rely on hybrid cloud by 2022. And 97% of IT managers plan to distribute workloads across multiple clouds. And the reason why was that they were looking to gain resiliency or meet regulatory and compliance requirements or leverage best of breed. And so we're going to see what actually happens in 2022. But the message is clear. The vast majority of organizations will be deploying in more than one type of cloud environment. So when it comes to database choices, our recommendation is that you want to choose something that can, across the board, or should we say across the cloud, a standardized path that will maximize the results of your migration efforts, maximize the results of your implementation efforts, and minimize anything that could be considered inefficient, redundant, wasted time and energy that's not adding value to your business. Another key decision that you'll be making if you go with a cloud-first strategy is what level of automation and control you want to have over your deployments. And I'm not going to be spending a lot of time getting into details about this because I want you to hear it from Vinnie about the considerations and the things that you should think about with these different choices. However, let's just say that it's highly likely that just as you'll be deploying in different cloud environments, private, public, on premises even, it's also very likely that you'll have situations where you're going to want more or less automation or more or less control over your cloud solution. And there are some applications where you might want to manage and set everything up yourself, and others where you're going to be happy letting the platform vendor make those decisions for you. However, our suggestion is that as you think through your cloud strategy from a database perspective, you think about what level of tuning and configuration control you would like to have. What level of routine maintenance, backup recovery, disaster planning do you want to take on yourself versus leave to the database service provider? Can you choose a database service provider that can handle all your needs across the different environments and service levels? And we'll be talking about these decisions a bit later. When it comes to deploying databases in the cloud, I'm sure most of you, if not all of you, are already familiar with Postgres and why it's such a great database, but it's worth reiterating. In fact, Postgres is one of the most popular database choices out there, and there are so many reasons, but I'm going to sum up with the 4 that always come to the top of my mind. 1, it's a very familiar database. It's a SQL relational database. Everyone knows SQL relational databases. It's really easy to get up and get started quickly. 2nd, trust. Postgres is enterprise grade. It's known to be reliable, secure. It's known to be at a level of sophistication of Oracle and other expensive commercial databases, but it's open source, so it's easily available to try and use. It's updated frequently. And so, people all around the world, many of whom work here at EDB, are paying attention and committed to continuously improving and making it a better and better database. It's also a high performance database. It includes things like parallelization of read queries, powerful indexing, multi-version concurrency control, all these things that you want out of a database, which are going to be, driving powerful and demanding applications. And it's really versatile. It's multi-model, it's extensible, it supports different data types. I could go on and on. It's our opinion that due to the popularity of Postgres and how great a database Postgres is, that the future will run on Postgres. It's going to run on Postgres in the cloud. Of course, in order for you to take advantage of this, it's not as simple and straightforward as just grabbing the first Postgres database you come across and jumping into building applications on it. You really need to think carefully about your decision, and we recommend you especially pay attention to 4 key things. First, what level of support and expertise do you want to have over your database? Are you going to hire tons of Postgres experts or do everything in-house? Or do you need a certain level of expertise in the database provider, someone who knows the ins and outs of the code, who can respond to any tricky, complex problems you might run into? What level of overhead do you want to take on yourself or offload to someone else? Do you want to hire an entire disaster recovery team? Or is this something that a database service provider can take care of via a fully managed solution? What about the opposite of automation and offloading? What about control? So let's say you're building a really valuable application that's critical to your business. What level of tuning configuration do you need to have within the database itself to ensure that you're extracting maximum performance from that database with regards to the application and supporting application performance? And lastly, if you're like the vast majority of organizations, that you're planning on using Postgres in multiple environments, on-premises, cloud, private cloud, public cloud, and do you want to deal with multiple contracts and database providers, or do you want some amount of continuity of support and services, both from a business perspective, like with regards to contracts and discounts and strategy and planning, as well as from a technical perspective, from the product perspective, like the interface and the feature set, or the technical support itself? So I know I just touched on a whole bunch of different topics, and I pose more questions than answers. And the goal is really to get you thinking about databases and cloud strategy and the various decisions that you'll be wanting to think about. But better than having a whole bunch of questions come up, right? The better thing is to get answers. And so for that, we have Vinnie. And what we're going to do is we're going to have a conversation with Vinnie. I'm going to ask him some questions about these topics. And like I mentioned at the beginning of the session, please feel free to chime in and participate. This is really about you and getting your questions answered. So let's dive in. So Vinnie, the first question I want to ask you is, organizations are moving to the cloud, and they're specifically trying to choose between platform as a service, software as a service, or perhaps infrastructure as a service. Can you talk to me about the differences between these various service models?
Yeah, I think it's very important when we start moving to cloud that we understand what those services are. So if you look to the left-hand side, you will see it's on-premises workload, and a whole stack response will lie with you. And then you tend to move towards the right-hand side, and you're delegating some of the core infrastructure responsibility to a provider. It could be you a managed hosting or a co-location provider or a data center in public cloud. It could be Azure, AWS. So you're delegating some of this underlying responsibility there. So essentially, you would allow to focus more on a business sort of goal and handing over the infrastructure to the expert, which actually can deal with that in the background. So I think it's very important to sort of aggregate, understand. But whatever we do in the cloud, doesn't matter what deployment model you use, you still own the data, the control around the access point, the endpoints, and then sort of your what we call is the access management as well. So if you manage your own Active Directory, you allow permissions level, but the cloud provider can take a lot of this burden from you and run this for you directly.
Can you talk to me about the difference of management responsibility between SaaS and Paas specifically?
So the SaaS is sort of a fully managed service which is offered by a third party or a cloud provider, and they take care of everything. So the application, the data, the storage part, all you do is simply consuming. So a real example would be the Zoom right now. We are in a dial-in a Zoom calls. It's all managed by the company. All we do is have identity synced into it and we do our works, but we don't care where the data is stored. Other example would be Microsoft Teams, OneDrive, and all these sort of artifacts which you use out of the box applications. They're a real example of sort of SaaS offering. In terms of Paas, it just varies where you have a sort of model where you custom develop code and applications where you have some sort of granular control required on the application side. Then it tends to be that the platform-wise and the underlying infrastructure is sent to a cloud provider, and you manage the application stack to make sure you optimize the application to meet sort of your requirement.
And how does a customer consume a SaaS versus a PaaS? Is it via a website or an application or something else?
I think I touched base earlier on a sort of example of would be. So I think the SaaS service could be available via applications, could be available by a website. PaaS is more of sort of custom code. You would have to plug that into your applications and you would expose that sort of front end, how you would allow somebody to access that application for yourself. So, but from a cloud perspective on, the cloud provider would actually build the service for you. It could be hosted into a sort of shared environment, could be hosted in a public cloud environment. But essentially, the only difference between is that the background is fully managed by, you don't care about the data is for sort of PaaS model. There's a lot of complexity around that, how you manage the application, fine tuning the data and other stuff that you have to take care of yourself.
How do you determine the best approach for your business? What are some considerations?
Okay, so I think it really depends upon what sort of a goal you are, how you're adopting cloud, what's your strategy for cloud is. You do want to focus on a business driver versus do you want to focus on infrastructure? I think it doesn't really add a value to you if you are a insurance company, your key business objective is to delivering insurance, go to market quickly. Why would you care where you actually run it? So I think it's important to understand that you start to delegate this responsibility to key stakeholder, which can take care of that in the background, and you try to focus on your key business driver in order to achieve that sort of success for your business directly.
Yeah, it's more about like focusing on what's actually delivering value to your business and kind of offloading the things that don't directly drive value to your business to somebody else, so you don't have to spend any time or energy on it.
That's exactly. I think we just have to find what we're good at it as the business wise, what our key strength is, and focus on those key strengths and trying to delegate. I think it's very important. We can't be successful. We use a lot of sort of shared service model, whether using ISPs, data center, there are a lot of shared responsibility across everywhere. We need to figure out, have that sort of trust and, visibility inside how a different service provider access what sort of security compliance. And we will tend to meet all those sort of security compliance as long as we are meeting all those business risk, then I think it's good to go ahead and, share that response with other provider as well in that space.
Thank you. Yeah, this is great. I'd like to kind of take it to the database kind of discussion and talk about there are a lot of different types of database. We're experts in Postgres, right? But there's so many different types. And can we just talk a little bit about the different categories of databases and what use cases different databases are good for? So
there are like a number of sort of way to categorize the databases. So these are some sort of popular ones. So you have relation data, key pair database, document-based database, you have time series database. And the key difference is that each one tend to lend towards the specific use case. They have this way of specially doing the modeling on the data, how the data would see. So example of the relation database that you have a massive sort of stack, you have schema defined, and you're defining the query in the front end. And so one of the choices in that one is SQL is very popular. And Postgres is sort of picking momentum in that space as a relation database as well.
Why would someone choose a graph database versus, say, a time series database?
I think, as I explained earlier, so the database tend to lend to a specific sort of task. So a graph database is sort of more creating a relation between quickly. So it would be an ideal case for a fraud detection or a social networking as well, because you are chatting with a lot of relation between the interaction point you're having. So that's sort of good sort of points to use it. Time series is more of like event-driven events. So if you are using a lot of IoT hubs, so you have a smarter motorways or you have smarter cities and other stuff, and you developing a lot of applications which are consumer-oriented, they're sitting in a field and you want to have that inside based on the time relations. Example would be a smart meter. So everyone has a smart meter electricity home. You look at the meter reading and the energy provider can bill you. So those sort of things are sort of time-based, how much you're consuming, what was the duration during the consuming the electricity. So there's a lot of examples where this that actually really fits. So that would be an ideal fit for IoT devices or event tracking devices.
Right. Could we talk about kind of how to narrow down which types of databases you might want to consider?
So when we're considering a database, there are lots of generalized form. People say it's a relation database, non-relation, SQL, non-SQL. It's very like 360-degree view. It's really difficult to pinpoint what exactly you want to know. So a lot of consideration goes around shape, size, and the computer oriented and how the data vary underneath. So this high level doesn't really give you that sort of confidence that you figure out what the right database would be in the cloud for you.
Can you kind of talk a bit more about that?
Yeah. So
quantitative.
Yeah. So when we talk about the sort of shape, so I think it's important. Is it a row-based data? Is it a column-based data? Is it key value pair data? Is it a graph, like we talked about an earlier example as a graph-based data? Then there are a lot of consideration go around to understand what exactly is. Then you would have sort of a size to consider. So in a size from how big is it? Is it small, big? But essentially, you don't really care about the overall size. What you care about it, how much the data I'm pulling if I'm making a certain set of query on a specific data set. Can be partitioned? Can be sharded? Because the underlying queries dictate how the performance of the database was vary. So it's very important to understand what is actually what my application actually really need. Or I'm not just making a high level overview that it's a relation, non-relation database. Do I need to really understand what would be the right for the cloud? Because each cloud provider tend to produce a different sort of service for each sort of use case example. So it's really important that you do some sort of background work to understand what actually your application really need for cloud.
And what about performance considerations? I mean, we know that Postgres, right, is considered a very high performance database. What are some things that you would want to think about with regards to performance when choosing a database?
That's a really good example. That's where we all focus the most. If you talk about, I don't think that people have, so when you have a discussion with the sort of DBAs, they more tend to be that I'm getting 1 million queries or a 2 million queries I want to write in 3 seconds. I think it's all driven by this IOPS, how much IOPS you're getting, because the database is actually sitting on a storage account and underlying infrastructure is delivering that performance which you need in order to compute. So it's really important to understand how your queries model. Once you start to understand the shapes and the size of the data, and then where the output is coming from there, then you're looking at the underlying sort of platform. How does the platform meet with sort of those queries? Is it responsive, not responsive? So IOPS is the one requirement. You do a lot of understanding about aggregations versus join function. Can you just partition this data? So a lot of consideration goes around to understand the fundamental of the database in order to make that sort of the performance consideration.
And then one of the other things I think I talked about was disaster recovery and backup and storage. So can you talk a bit about storage options?
Yeah, so I think the backup and disaster recovery is very critical to business. So if you are designing a mission critical application which means you can't tolerate failure, it's important to have a fail-safe scenario. If something goes wrong, what would happen? So whatever we're designing today, they all have built this sort of recovery into it, whether you're buying a car versus you designing an airplanes, whether you're designing a rocket to go to the moon, whatever they have this fail-safe scenario. So we cannot run a sort of production ready or critical application, tier 1 application of cloud without no backup. So I think, so a lot of consideration goes, the cloud is sort of very tactical. There are a lot of platform as a service available in the cloud. So if you have running something in Azure today, you can use a site recovery to replicate the data from one location to another one. If primary reason goes down, it's possible you can quickly recover with automations. So then it depends upon how your application behaves. Not every application is fully automated. So there are various scenarios, active, passive, or active, or that you have sort of where you just want to build a sort of fail-safe scenario for a business continuity perspective, not as an actual DR. So a lot of consideration. And so cloud provider give you a lot of choices in terms of how would you replicate. There are choices that if you're running a data, you can use storage level replication to replicate the underlying, the backups to one location to another one. You could use a high level platform as a service to replicate the whole infrastructure versus the database. And there are a lot of environments since the Azure started back in 2020, there's a lot of environments, it was more legacy. Now there are a lot of advancement happening into sort of cloud platform. They're learning from the client experience, they're learning from engagements, and they're developing more and more tools to streamline that experience that it's just available to you out of the box natively in the cloud today.
Awesome. Thanks. I think that we've kind of touched upon some higher level topics about overall, what type of automation control you want, what type of service model, what type of database. And I would love to kind of start talking a bit more about specifically what you're hearing as you talk to customers about the types of challenges that they're facing with their databases, that they look to implement cloud databases, and kind of, what they're trying to accomplish with those databases. So can you talk to us a bit about that?
Yeah, I think it's well and good that the service available in cloud, but it's not as simple, straightforward to consume those cloud. There are always some driver which you haven't considered before, start consuming them. So we've been having a discussion with a insurance client based in UK, which is quite concerned about the performance and sort of expertise on a SQL space in order to use those sort of cloud space. So it's one of our insurance and saving account based in the UK. They rely heavily on a sort of Postgres as a mission critical application. So they're running around right now Postgres 11, and they're in this dilemma that they can't upgrade because the application doesn't sustain sort of downtime. And it's really difficult to switch to leverage the latest platform offering from an older version to new version. So there's sort of a lot of challenge around. Now, as more and more we're pumping the data into cloud, the data is getting bigger and bigger, and then it just gets slower and slower. So then you really need to sort of understand, how do we best optimize? What's the temperature of the data is? How hot or cold or warm my data is? Is it a way for me? Is that legacy data I don't have to use every day? Or is that sort of frequent active data set which I'm actually consuming? And then a way to figure it out, to have sort of microservice approach to it, dissect your application in such a way that active data stays into a different sort of segment in the application, the rest data is there. But I think it's really have to have the deeper conversation in order to understand how deeper we can go to really understand our applications and best optimize the cloud. But even if you go forward today and use the biggest option, so they're using the biggest option in Aurora today, they max out on every single limit. They have roughly around a 2.6 billion document where they ingest in a cloud, and it's getting slower. It takes so last time they had a sort of indexing done, it took them like 37 hours to just indexing on a database in Aurora. So a lot of challenge around. And another thing is that the cloud provider trying to increase the cloud adoptions, they're providing all these tool sets to allow business to adopt cloud quickly. Obviously, they don't have that sort of key core strength in a Postgres. So the lack of skill set, yes, they're good with the cloud, they're good with everything else, but it doesn't mean they're good with the database as well. So essentially, the business has to think about, is there a right partner I can partner with to add some of the challenge I'm actually experiencing in that space. Mm-hmm. Mm-hmm. Now, we have another European client, which they launched back in 2013. They started with a small company in one of the European countries. Now, by fast forward 2021, they are actually holding around 39 million COVID vaccinations appointment for healthcare in India. That's a big, large number. And they max out everything in sort of Amazon directly today. So there's a limitation around how much vertical and horizontal you can scale. So take an example of Aurora today. Aurora, you could have a one writer and up to 14 sort of replica set, and they're exceeding the limit. Then you have a scale of the horizontal scale that you have a certain set of SKU available for each data set. And they're using almost like max out SKU in like 24x large, or just one number down. In 6 months, they want to hit that limit as well. So they're concerned about those things that, yes, it's a fully scalable data, but there's a limit to everything what you can scale. So it's all boiled down. Do you really understand how your data works? What is actually I can do around the data to understand how better I optimize my cloud spend? So because essentially whatever you're spending in a cloud, it has a massive impact into in a cost model as well. If cloud is not free, when you start spinning up resources, there are a lot of adds up into the monthly or annual cost of an application itself.
I think those are great examples. I mean, thinking about database usage longer term and how it's going to grow for your business, thinking about what type of performance you need and what type of support you're going to need from the database service provider. Those are all really important key things. I know that the webinar was scheduled for about half an hour, and so we're kind of running up on time. So what I'd really like to do is very quickly talk about our newest offering, BigAnimal, and that we came out with last year, that kind of responds to the things that we've been hearing from our customers about what they need from a cloud database, and talk about an example of a customer that you've talked to that is a really good fit for this type of solution. Sure. So Vinnie, would you like to go through kind of?
So BigAnimal is our sort of similar offering as any cloud service provider offer. It's our fully managed Postgres as a service in the cloud today. And we designed the service based on feedback receiving. EDB is in that space from the last 14 odd years, and we work on the premises environment with customer, and they really trust us. So based on our experience and recent acquisitions with the second quarter and back in 2020, we developed this service based on microservice approach. It's fully automated, agile infrastructure, which you can spin down, tear down, and you have all sort of control like you would have a cloud provider. You are using UI, CLIs, and APIs. And if you have a specific configuration requirement, which is locked down in sort of cloud provider where they don't give you sort of super user access to allow add extension database, we are that company which really thinks about that. It's very important. Sometimes the customer really need a control. So it meets those sort of specialized use case scenario where you can actually tend to have those sort of additional granular control in your database in order to meet those sort of database sort of schema, other requirement as well. So it's available today in Azure. Anyone can go and try this service. And I think the key value proposition we want to create. So we had a sort of two key areas. One is sort of our Postgres expertise. We have a lot of developers and our colleagues which contributing to the core Postgres itself. We have a lot of visibility into the Postgres, the bug fixes, the roadmap for fixes. So that really adds value to us that we can quickly see what's going on and how quickly can we release those bug fixes into our offering directly as well. And I'm sure you heard before as well, EDB has a enhanced version of the Postgres, which is our enterprise offering on the top of the Postgres 360 Community Edition, which allow us to organizations to transfer directly from oracles to our Postgres versions. So it's available out of box. We provide a lot of tons of migration toolkit offline, online based on as well, where you can actually run your schema checks. Do you figure it out how much compatible you are with actually going to BigAnimal state of it today? Now, obviously, when you go to cloud, scale is very important. We talked about an example how you're hitting the scale. So our service is built on sort of that scale that you can from a 2-node CPU to all the way to 64-node CPU to a 2 CPU to a 96 CPUs with a tons of various level of VM SKUs available for you to consume today. The service is available in Azure as of now, but by the second quarter of this year, we would be in AWS. And by the second half this year, we would be into our GCP as well. So we are fully cloud agnostic, fully automated, fully agile. We'll give you access to a UI APIs as well. Then you can consume the service today.
Awesome. And kind of let's talk about what an example of a good fit for this solution would be.
So we've seen a lot of interest in our offering, and we feel like everyone has a cloud strategy or a Postgres strategy or a microservice-based strategy. They want to have a fully managed service. We are right fit for them in this space today. But this is an example of a non-profit organization based in US, which works with a lot of students to produce that sort of compelling materials to allow them to graded by universities and give them a chance to compete in a sort of world. And so they are actually relying on from BigAnimal today. So they have a sort of programs that they want to have a fully managed service in the cloud, fully operated and managed by EDB as an expertise. And so they want to scale out from a 40 university to all the way to 80 university in year 22. That scale is already built in the cloud. You can just we provide a sort of a multi-tenant environment. You could deploy this sort of artifact to any subscription you want. If you engage with a client, you manage their subscription, you deploy their artifact in there. So there's fully possible that you can have multi-tenant, multi-subscriptions, all those scenarios play out for you to consume the service. Awesome.
Thank you, Vinnie. Well, I think we're out of time. And for anyone who asks questions, we will definitely be circling back to address them. But I would like to thank Vinnie for taking the time to talk to us about what he's been seeing and learning and hearing as he talks to customers, and for taking the time, everyone in the audience who took the time out of their day to listen to our discussion. I hope you found it useful, and I'm going to pass it to Jasper to help close out.
Yep. I'm just going to echo everything that Christina said there. Thank you all for joining us for this webinar today. We will be getting a recording to you. Look for it around this time tomorrow. I hope you all have a great rest of your day, and thank you for joining EDB for this webinar.
Thank you, everyone.
Thank you all. Bye-bye.